Welcome to yet another video. So if you're like me, you're staring into a blank piece of paper, trying to solve a time complexity problem, and you're trying to figure out how to go about it. You're doing the best you can, but you simply cannot do it. Simply doesn't make sense. And you want a way out. Well, I'm here to tell you something. Today we're going to cover how to come up with Tn expressions for recursive algorithms with the goal of analyzing some complexity. So without further ado, let's get started. So let's look at this first example. We have public int factorial, and then we're taking the value of n as a parameter, right? So straight from this, we have factorial n, right? This will be translated to t of n, right? And the idea is every time this function is called, right, with some value n, that's going to amount to t of some value n, right? So let's have a look at this example. They say if n is equals to 0, return 1, right? So we write our initial Tn expression, meaning the Tn of factorial is equals to, now we're going to analyze the if part of the if statement. We're just returning the value of n. So I'm going to count that as c, some constant time operation, right? And thereafter, I'm returning n times factorial, right? I'm returning the value n times factorial, right? So I'm assuming that multiplying something is c, and returning something is also c, right? So this one was for the if statement above, returning 1. This one was for multiplying n with factorial, right, in the else clause. Then this one was for returning whatever value was calculated there. But then we have plus t of n minus 1, right? You read this straight off the formula, right? And then if we simplify this, we're going to find that we have t of n minus 1 plus 3c, right? Meaning we have a total of 3 operations that run in constant time, right? Let's look at the next example. So this was example A. I want us to look at the next example. Look at the next example. So in this example, we have a similar problem over here, but now we're dealing with Fibonacci. The function is called Fibonacci. So we're going to start off as t of n is equals to, and this t of n is similar to the method name, and then you give it a value of n. So keep that in mind. So the if statement reads if n is less than or equals to 1. So that's one comparison operation. And then we have return n, that's 2 comparison operation. So we'll write that as 2c plus, outside the if statement we have return, call that as c because we're returning something. And then we're calling the function again. But what's the input this time? It's n minus 1. So we're returning Fibonacci brackets n minus 1 plus, right, Fibonacci n minus 2, meaning t of n minus 2. And we're adding those, so that's another c. Let's make this 2c. Okay, let's simplify this. We have t n minus 1 plus t n minus 2 plus 4c, right? So this example, I have the towers of Hanoi problem. Right? When you look at it, it seems quite scary, but let's have a look at it. So we have, initially, I'm going to call this problem C, t of n we have y. So this is similar to saying towers of Hanoi. Remember, again, this is the method name, and then the size of whatever it is we're going to search through, right? What does this read? If n is equals to 1, so we have one comparison operation, right? I'll write that as C. System.out.println, so we're printing something. So we're assuming that that's also C, that's one constant operation. And then we're returning, right? So in the if part of the towers of Hanoi problem, we already have 3 operations, right? And then what happens outside the if statement? What happens outside the if statement? We have towers of Hanoi called again, right? But what's the input? What's the value of n this time? N minus 1. Look carefully, right? I'm gonna highlight it on the problem, right? So look carefully. And then we have another print statement, right? So we're assuming that that's one constant operation. And then again, we're calling this method again, but this time n minus 1, right? If we simplify this, what do we have? 2t n minus 1 plus how many c? 4c, right? Let's look at one last one so that you really get the hang of this. So this is the last example that we're doing over here. We have public int power x comma n. So this method is used to calculate the value of x to the power of n. So you put in the value of x, you put in the value of n, and then it gives you an answer, right? So let's look at how it's defined. Let's look at its an expression. We have t of n is equals to what? Pause this video and then do it before watching the answer. So I'm going to assume that you've done that, so let's continue. We have if n is equals to 0, return 1. That's 2 operations because we're comparing n to 0 and we're returning the value of 1. So we have 2c. That's from the first if clause, right? Then we proceed to see else if n mod 2 is equals to 0. So if our n is an even number, that's one comparison, right? We're returning, let me write this manually, clean this up. I'm just gonna 2c, scratch this out, I'm creating space over here. What do we have? 2c for the first if statement, right? And then let's move on to the else parts. So if n mod 2 is equals to 0, 1 for the if statement comparison, 2 for returning, 3 for multiplying, and then we have 3c, and then we call our method again, t of n over 2, because that's the value of n, plus t of n over 2 again. So we're calling this method twice, right? We're not done yet. So we have if n mod 2 is equals to 1, that's one comparison. We're returning something, that's another operation, right? Then how many times are we calling our power method with the value of n being n over 2? We're calling it 2 times. And then the last one, we're calling it t of 1, right? So if we simplify this, let's look at it. Okay, before we proceed to simplify, we have another else clause which returns the value of 0. So we simply say c. So let's simplify this. How many c's do we have? We have 1, we have 2, we have 5, we have 7. So we have 7c plus how many t n over 2's do we have? Quite funny to say that. T of n over 2, so we have 1, 2, 3, 4. 4 t n over 2 plus t of 1, right? And if we write it more neatly, if you want to write it the classic way, we have 4 t n over 2 plus t of 1 plus 7c, right? Right. If you come this far, then you really understand how to come up with the T expression for any recursive algorithm. In the next video, we're going to cover how to calculate the time complexity for all these problems over here. I'm going to share with you simple steps you can apply to any T expression problem. If you find value in this, be sure to click the like button and subscribe. Alright, thank you. Take care.